Hello everyone. Today we will explore one of the most important topics in logic, the rules of inference. These rules help us draw valid conclusions from given statements or premises. These are the rules of inference. We will go through the 9 basic rules with example. So let's start with the rule of simplification. It states that if you know P and Q are both true, then you can conclude that P is true. Symbolically, that is, if P and Q, then that is proposition P. For example, it is raining and it is cold. So the proposition P is it is raining, and proposition Q is it is cold. Then the logical connector is AND. So the conclusion will be it is raining, which is the proposition P. You simplified the conjunction into one of its parts. Next, the rule of addition. If P is true, then you can conclude P or Q is true for any statement Q. Symbolically, that is, if P, then P or Q. Example, the cat is sleeping. So this is the proposition P. So the conclusion will be the cat is sleeping or the dog is barking. So the cat is sleeping, that is proposition P. The dog is barking, that is proposition Q. The logical connector is OR. Symbolically, we use this. Okay? Even we don't know anything about the dog, the statement P or Q is true because the proposition P is true. Next, the rule of conjunction. So the rule of conjunction, let us combine two true statements into one. So if a P is true and Q is true, then we can conclude that P and Q is also true. Symbolically, that is, if P and Q, then P and Q. Example, the sun is shining. That is the first premise. The sky is blue. Okay, so we have the sun is shining, that is proposition P. The sky is blue, that is proposition Q. So the conclusion will be the sun is shining and the sky is blue. So we have proposition P, the sun is shining, the sky is blue, that is proposition Q, with logical connector AND. And that is a rule of conjunction. Next, modus ponens or the rule of detachment. So one of the most powerful rules is modus ponens. No? If P, then Q is true, and P is true, then Q must be also true. Symbolically, that is P. If P, then Q and P, then that is the proposition Q. Example, if it rains, the ground will be wet. It is raining. So, if it rains, so that is proposition P, the ground will be wet, that is Q. So, it is raining, that is proposition P, and what will be the conclusion? It says that is proposition Q. Therefore, the ground will be wet. So, you detach Q from the conditional ones. P was confirmed true. That is modus ponens, or the rule of detachment. Next, modus tollens. Okay? So, the opposite of modus ponens is modus tollens. So, it says that if P then Q is true and Q is false, then P must be false. Symbolically, that is P implies Q and not Q, then not P. So, example, if the light is on, then electricity is flowing. So, the light is on, that is proposition P. Electricity is flowing, that is proposition Q. So, the logical connector is if then. This is the symbol. And electricity is not flowing. It says that we will negate the proposition Q. So, that's why we have electricity is not flowing, which is not Q. So, the conclusion will be not P, and that is the light is not on. So, this is not P. Next, the law of syllogism. So, the law of syllogism allows us to chain conditional statements. So, it says that if P, then Q, and Q, then R, then we can conclude that P implies R. So, in symbol, we use this one. So, the conclusion will be P implies R. So, example, if I study, then I will pass the exam. So, I study, that is proposition P. I will pass the exam, that is proposition Q. And we use if then. So, this is the symbol. Then, if I pass the exam, that is proposition Q. No, this one. Then, I will graduate. So, I will graduate, that is proposition R. Again, we use if then. So, the conclusion will be P implies R. So, P implies R. So, the conclusion will be, if I study, then I will graduate. So, P implies R. You can think of it as connecting the dots in reasoning. Next, the rule of disjunctive syllogism. So, this rule eliminates one part of an or statement. Okay, so if P or Q is true and P is false, then Q must be true. No? So, symbolically, this is the standard form. Therefore, the conclusion will be Q. Example, either the teacher is in the classroom or in the office. So, the teacher is in the classroom, that is proposition P. The teacher is in the office, that is proposition Q. And we use or. Okay? So, next, we have to negate the proposition P. Okay, so that will be the teacher is not in the classroom. So that is not P. Therefore, what will be the conclusion? That is, the teacher is in the office. And that is proposition Q. Okay. This is the rule of disjunctive syllogism. Next, the rule of contradiction. The rule of contradiction helps us show that something is false by assuming its opposite leads to a contradiction. If assuming P leads to a contradiction, then not P must be true. So this is the symbol, so the conclusion will be the proposition P. Example, suppose we assume the number square root of 2 is rational. So that assumption leads to a contradiction in mathematics. So we can conclude that square root of 2 is not rational. So this is the foundation of proof by contradiction. And lastly, we have the rule of proof by cases. So if you can prove R from case P and also prove R from case Q, then R is true whether P or Q happens. So this is the symbol. Okay, so example, it's either morning or evening. This one. If it is morning, the lights are on. If it is evening, the lights are on. Conclusion, the lights are on. No matter the case, morning or evening, the proposition R holds true.